Hi guys, today we're going to learn today we're going to do chapter 1 just chapter 1 test part 2. So this is part 2. Okay, so let's get started. So the first problem of part 2 of chapter 1 test is it says perform the indicated operation and write the answers in standard form. So we have this we got to write this in standard form. So in standard form, remember they wanted an a plus bi. This is standard form, right? So we're dealing with imaginary numbers. So first step is FOIL everything out. So you got to FOIL it out. This is not a perfect square, right? Wait, is this? No, this is not a perfect square because this 2 this should be a 3. So we can't do one of the shortcuts. So this is you just have to FOIL it out. So 3 times 2 is 6. 3 times 3i is positive 9i. Negative 3i times 2 is negative 6i. And then negative 3i times positive 3i is negative 9i squared. And keep in mind, I squared is equivalent to negative 1. So remember that rule, because that will come in handy. So let's simplify. This is like saying negative 9 times I squared, so it's like saying negative 9, and we said that I squared is negative 1, so it's negative 1. This is 6 plus 9i minus 6i. Negative 9 times negative 1 is positive 9, right? Let's see here. This is just 6. Now, we can combine the i's, right? This is a 9i and a negative 6i. What is that going to be? 3i, positive 3i. Okay. So let's simplify. We got to put it in standard form in a plus bi. So let's combine the whole numbers. So 9 and 6 is what? 15, right? And then you're just left with positive 3i. So this is in standard form. So this should be your final answer. Okay, that was a simpler one. Now let's do another one that involves conjugates. We'll call this part, this is B. So let's say we have 13 minus I over 5 minus 3i, right? Same question says perform the indicated operation, write the answers in standard form. But this time, before we got to take the conjugate of this one. So what do you think my conjugate is going to be? Well, you usually start with you start with the denominator. Sometimes you can start with the numerator. So we look at our denominator. So this is our denominator. The conjugate of that is always the opposite sign of this. So the conjugate of this is going to be 5 plus 3i. So that's our conjugate. So you got to multiply top and bottom by that. 5 plus 3i. Okay, so let's fix the numerator. Let's focus on the numerator. So let's FOIL this out because this is not a special rule. This is not a perfect square, so let's FOIL it out. 13 times 5 is 65. 13 times 3i is 39i, positive 39i. Negative I times 5 is negative 5i. And then 3i, or negative I times 3i is negative 3i squared. Right? Now let's do the denominator. This is a perfect square. So you could do the perfect square rule, or if you don't know that rule, you could just simply FOIL it out. So the perfect square is like a plus b, a minus b, that becomes our a squared minus b squared. So my a is 5, right? So this looks like this, right? We got to make it look like the right side. So my a is 5, and then we got to square that, so it's 5 squared minus, and what is my b? So a is 5, my b is 3i, right? But we got to square that, so it's going to be 3i squared, this whole thing. So let's simplify the numerator. Let's fix the numerator. So it's going to be 65 plus 39 I minus 5i minus 3. Remember we said that I squared is -1, so it's going to put a -1. Let's simplify this. So -3 times -1 is +3. We have a 39i and a -5i. So what is that? So bring down the 65. 39i minus 5i is 34i. So this becomes a 34i. Let's simplify it. So let's collect our whole numbers. 65 and 3 is what? 68? Yeah, 68. So this becomes 68. And then we're just left with 34i. That was just our numerator, right? That was just our numerator. Let's fix, now we got to do the denominator. So 5 squared is 25 minus, okay, so it's 3i squared. So you got to square the I and the 3. So 3 squared is 9, and then I to the second power is I squared. And remember I squared is -1, so it's going to be -1 times, and then we have distribute that -9, so it's -9, and then bring down that 25. So -9 times -1 is +9, and then bring that 25. So 25 plus 9 is 34. So if we were to simplify it, it's 68 plus 34i divided by all over 34. Now remember, this 34, you're dividing this whole by everything. So remember, you have to, there's like two parts, 65 and 34. You're dividing 68 by 34, and then 34i divided by 34. What is it? We can actually simplify that. 68 divided by 34 is 2. And then 34i divided by 34 is just 1i. Or you could just leave it as I. Same thing. So this is my final answer. Yeah, so for this one, we had to take the conjugate and then multiply top and bottom by the conjugate. So let's do part C. So erase this part. So remember, I squared is -1. So C says, I think it's the same style. We have to take the conjugate. So 7 plus I over 2 plus I. So I got to put it in standard form. So what do you think my conjugate, so yeah, we got to take the conjugate and multiply. So what do you think my conjugate is going to be? So we just look at their denominator, which is 2 plus I. So the conjugate of that is the same thing, but it's different sign. So it's 2 minus I, right? And then you just multiply that top and bottom by 2 minus I. Let's fix the numerator. So 7 plus I times 2 minus I. It's not a perfect square, so you just got to FOIL it out. 7 times 2 is 14. 7 times -I is -7i. I times 2 is positive 2i. I times negative I is negative I squared. And then let's do the the denominator. This is a perfect square, so it's 2 squared minus I squared because my A is 2 and my B is I. Okay, let's fix the numerator. Let's simplify the numerator. So we said that I squared is negative 1, so there's a minus and then a negative 1, right? So it's 14 minus 7i plus 2i, and then 2 negatives becomes a positive, so this is positive 1. Let's simplify that even more. Let's collect the whole numbers. So we have a 14 here and a 1 here, so that's 15. And then we have a negative 7i plus a positive 2i, which is negative 5i. Good. So that's my numerator. Let's fix the denominator. 2 squared is 4 minus, remember an I squared is a negative 1, so it's a minus and a minus 1. So 2 negatives becomes a positive. So 4 plus 1 is 5, so it would be 15 minus 5i. 4 plus 1 is 5, so this is going to be 5, right? Now we have to divide that 5 by this two parts. Remember we have 15 and a minus 5i, so divide that 5 by both of them. So 15 divided by 5 is 3. Negative 5i divided by 5 is negative I. And this is in standard form, right? So it's in a plus bi form. So this should be your final answer. Okay, so that was that one. Ah. Oops, can't erase it. Okay, so what about this one? That was C, so let's do D. This one we kind of have to, so we have 2 minus I square plus 3 times 2 minus I, right? Minus 5. Okay, so the question says, yeah, we got to put it in standard form in a plus bi. So let's simplify this. Let's simplify this 2 minus I. This, you could actually, if you don't know the rule, you can just FOIL it out. Or you could do, this is also known the perfect square. Trinomial. So if it would, the perfect square trinomial is something like this: a squared minus 2ab plus b squared equals a minus b squared, right? So this part looks like this because this looks like this. So we got to make it look like on the left side, right? We got to make it look like this. So we just got to figure out what's my a. My a is going to be 2, and my b is going to be I. So you just put it in this, it's a squared. So you could do 2. So our a is 2, so you got to square that, minus 2 times a, which is 2, and my b is I, right? So I'm putting it in like in this formula, plus b squared, which is I squared. We can simplify that. So 2 squared is 4, and then negative 2 times 2i is negative 4i. And remember that I squared is negative 1. So we could simplify this even more. So 4 minus 1 is 3, and you're left with negative 4i. So we simplified this part. Now let's simplify this part. We got to FOIL this out, right? So 3 times 2 is 6. And then 3 times negative I is negative 3i. Good. And then we don't do anything with this, so we just bring it down, so it's just negative 5i. Negative 5, not 5i. Now we just collect like terms. Let's see here. I'm going to box all the whole numbers. So we have a 3 here, positive 6, and a negative 5. When you combine all that, 3 plus 6 and a negative 5, you're going to get 4. Positive 4. Now I'm going to circle all my imaginary numbers. So we have a negative 4 here and a negative 3 here. So when you collect that, that's going to be negative 7i. Is this in standard form? Is it in a plus bi form? Yes. So this is my final answer. So that was D. Okay, let's do E. Let's say we have 6 minus square root of negative 64 over 2. So we got same rule, we got to put it in standard form. But before you look at this, we can simplify this even more. We cannot have a remember, we cannot have a negative inside the radicand. So we're going to use this rule where I equals negative 1. So what you do is you take out that negative I, that negative becomes an I, and then you take the square root of 1. Or you can use this rule as well, negative I equals negative square root of negative 1, right? So when you have a negative here and then you have a negative in the radicand, you're just left with negative I. So how would I rewrite this? I could say negative 6 minus, we can't have that negative, but you do is take out that, you factor out an imaginary number or an I, and then you're left with 64 over 2. Let's simplify this even more. So let's fix the numerator. The square root of 64 is 8, and then you have an times it by I, so it's going to be 6 minus 8i, right? Because this is multiplication over 2. Now, we're almost done. See this 2? We got to divide it 2 for this part and then this part. So what is 6 divided by 2? 3. What is negative 8i divided by 2? Negative 4i. And then this is in standard form, so in a plus bi form, so this is your final answer. So that was E. Let's do F. So question says simplify I-21, I to the 21st power, I to the 43rd power, and then I to the 52nd power. So I to the 52nd power. So let's simplify these. Now this kind of does seem a little tricky because you're dealing with really high powers, right? 21st power, 52nd power and stuff, etc. So keep in mind, you might want to write this down. This is given. This is something you would find in your textbook. I equals I squared is -1. So these are just rules. I cubed is -I. And then I fourth is +1. I fifth equals I sixth is -1. I 7 is -I. And then I 8 is +1. So this was given on a textbook. So you might want to memorize this. How I can memorize this is like, so this is, look at this is an odd degree. It becomes positive. When it becomes an even, it becomes a -1. And then it repeats itself. This is odd, and then becomes a -I, and then I fourth is +1. I to the fifth is I to the sixth is -1. So do you see the pattern? So this was an odd degree. And then how did they get I, like, if you do get curious, how did they get I to the fifth +1? So it's like saying I square times I square, and then times it by I. We know that I square is -1, so that's -1 times -1, and then times it by I. So that's -1 times -1 is +1, and then that times it by I. So that's how you get I to the sixth, I to the seventh, etc. So this is something you might want to remember. Now, we use that rule, so let's figure out what I-21 is. How can we rewrite I-21? How can we write I-21 given these rules? So we could say, couldn't we rewrite I-21 as I seventh, raise it to the 3 power? Because remember, when you're raising exponents, you're multiplying the exponents. So that it's like saying this is equivalent to I-21 as I7 raise it to the 3rd power. So what do we know that I7 is -I, and then we just got to raise that to the 3rd power. So that's like saying -I times -I times -I, right? This becomes what? -I times -I is +1 I square, and then times it by -I. We know that I square is -1, right? And then times it by -I. So your final answer of I-21, it's just wait, hold on, did I do this right? Yes, 7 to the 3rd is 21. We know that I to the 7 is -I. Okay, so good. -I times -I is +I square. And we know that I squared is -1. Oh yeah, there I go. And then -1 times -I is just +I. So I to the 21 is just +I. Good. Let's do I to the 43rd power. So how can I write I to the 43rd power? I can rewrite I to the 43rd I can rewrite I to the 43rd is I to the 7th, and then we could raise that to the 6th, right? But that's like gives us I to the 42nd power. We want I to the 43rd, so we just got to multiply it by an extra I, and that'll give us I to the 43rd power. So what is my I? What is I to the 7th? I to the 7th? Negative I, right? And then you just got to raise that to the 6th power. So, negative I square times negative I square times negative I square gives me I to the 6, right? Yeah, because remember, when you're multiplying exponents, you're really adding. So this is like saying I to the 6. So I square is negative 1, but there's a negative, so it's two negatives, right? So this becomes positive 1 times positive 1 times positive 1. That becomes 1, but don't forget, we got to multiply this by I, which is I squared, which is negative 1. Wait, did I make a mistake? I think I made a mistake, right? So we got to rewrite, I'll just rewrite it as a whole. So negative I times negative I, I'm going to multiply this by 6 times. That'll give me I6. So this is 1, 2, 3, 4, 5, 6. This gives me negative I6, right? 1, 2, 3, 4, 5, 6. So negative I times negative 1, negative I is positive I square. This becomes a positive I square, right? And then this becomes a positive I square. Remember, we know that I square is a negative 1. So and then you times that by also another negative 1 and also another negative 1. So this becomes, two negatives becomes positive, and then you're left with a negative 1. So it's just negative 1. And then you multiply that by I, right? So your final answer is just negative I. So I to the 43rd is negative I. Okay, so let's do the last one, I to the 52nd power. So how do I write I to the 52nd power? I can rewrite that as I to the 4th, raise that to the 13th power, and that'll give us I to the 52nd. So I to the 4th, if we look at our chart, is positive 1. And then you just raise that to the 13th power, and we know that 1 to the 13th power is just positive 1. So that's your final answer for I to the 52nd power. Okay, so this wraps it up for part 2 of exam 1.